All right, boys and girls, today's lesson is lesson 2-6. And actually, we're going to knock out just real quickly 2-5 also. 2-5 talks about the factor of 7. And we're going to knock that out real quickly and then go on to 2-6. So to get started, turn to page 108 in your book. So we're going to quickly just kind of talk about the sevens. The sevens is really not a trick when you're working with the sevens factors. Just because it's the ones and twos and threes can be easy, fives are easy, tens are easy, nines have their little tricks and patterns. But when it comes to like 6, 7, 8, and 4s for that matter, there's not a whole lot of tricks for it. So it's just something you kind of have to start remembering. So I know a lot of you are getting really good with your 7, your factors of 7, or your 7 multiples of 7. Well, let's just quickly kind of go through this. You understand the fast array drawings, meaning if it tells you the two numbers on the outside, that means that's a factor and a factor. That means it's multiplied to get 28. If it tells you the number on the inside, which is the product, and one of the factors, you take 42, divide it by 7 to get 6. Or you might be able to just say, okay, 7 times what number gets me 42. Number 3, same thing. You multiply the two outside, you get 30. I'm just gonna fly through a bunch of these. I'm gonna have you finish the rest on your own. But 24 is the product. Here's one of the factors. That means the other factor has to be 8. Here you have the two factors, so you multiply and you get 48. Here you have the product and the factor. 10 divided by 5 is 2. Same thing here. 36 divided by 6 equals 6. 56 divided by 8 equals 7. Here you have the two outside numbers, which is 3 times 4 is 12. Here you have 7 times 7, which is 49. Here you have 35 as a product. 5 is one of the factors. Divide it, you get 7. 63 is from multiplying 9 or 7 times 9. Easy one when the two are on the outside to give you 48. Here 4 times something gives me 24. I know 24 divided by 4 is 6. Here you have 54 divided by 9. 9 times something is 54, and that's 6 also. All right, so we just kind of quickly flew through that. I didn't find it necessary to make that a whole lesson. So I'm going to push that aside. I want you to turn to the next page. And I want you to talk about square numbers. Okay, square numbers are when the product is found by multiplying the two factors, and the two factors are the same factor. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. And it could go up to 100 times 100. It goes up to whatever numbers you want, as long as the two numbers you multiply are the same. Okay? So if your answer or your product is found from multiplying two factors that are exactly the same, your product is a square number. Okay? So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 16, 25, so on. And here you get 1, 2, 3, 4. You get 10,000 for that one. These are all square numbers because the factors are the same. This on this page, these are squares, clearly because they have the same amount of, all sides are equal. So if a square has all sides are equal and they're filled with the same amount of little area squares on the inside, then your answer, or the amount of squares on the inside, would be a square number. So 1 times 1 equals 1. Well, we have 1 times 1. Well, I just did the perimeter. But 1 times 1, we have 1 going that way, and we have 1 going that way, because it's the same one. That's all it is. So it's 1 times 1. Here we have 2 going across the top, and we have 2 going down the bottom. So that's 2 times 2 equals 4. Here we have 3 and 3, so 3 times 3 equals 9. Here we have 4 and 4, So 4 times 4 would equal 16. Hope you get the idea here. So what I want you to do is I want you to pause it and do 5 through 10, and then unpause it and we'll talk about it. Okay, well hopefully you unpaused it, and what you got is you had 5 squares going across the top, 5 squares going down, gives you 5 times 5 equals 25. I really should have square units here. Each of these should be in square units, because that's really what it is. Here we have 6 and 6, so 6 times 6 equals 36. I'll let you fill in the square units. Here we have 7 times 7 equals 49. 8 times 8 equals 64. 9 times 9 equals 81. And then we end with 10 times 10 equals 100. Okay, so all of these products are square numbers because they're found by multiplying two factors that are the same. So, on the next page, now I have to find it because I accidentally tied it in with the other one. It says list the products in the exercise 1 through 10 in order. Discuss the patterns you see with your class. Well, I'm just going to do it for you. The products in order are 1, 2, 3, 4. Whoops, I'm sorry, I did it completely wrong. The patterns are 1, 4, 9. What did we say? 2 times 2, 3 times 3, 16. 25, then we did 36, 49, next one was 64, 81, and 100. Okay, do you see any patterns? Well, I know it goes plus 3, and then here it goes plus 5, there it goes plus 7. So it seems like the difference between them each time is 2 more. Because the next time is 9, and then you have 11, then you have 13, and then you have 15, and then you have 17, then you have 19. So that tells me the next one would be, let's see, 21 more on that, so it would be 121, right? So that would be 11 times 11. So this is the main part of the lesson right here. It says the numbers you listed in exercise 11 are called square numbers. Okay? So all of these are square numbers. Okay? Because they're areas of squares with whole number lengths of sides. A square number is the product of a whole number and itself. Meaning, take a factor and then double it. Match that factor, not double it. I guess multiply it by that factor. So if n is the whole number, then n times n is a square number. So that means if we had n and n represented whatever n would represent, you could say n equals 7. So that if it was n times n would equal a square number because you're multiplying n times n, and we told you n was 7, so it's actually 7 times 7. Okay? So here are patterns on a multiplication table. It says in the table below, circle the products that are square numbers. Discuss the patterns you see with your class. Okay. Well, I want you to do this. I want you to find all the square numbers, and then when we're in small group, we're going to discuss it. So why don't you work on the square numbers, circle them all, and then off to the side here, I just want you to write about the pattern you see, if you see any patterns. And write any other notes you'd like to share with the small group about square numbers.